Hi, I'm Cheryl Leach. In this problem, we're going to be using Newton's method to help approximate the zero for my function x cubed plus x minus 1. Now, Newton's method is an iterative process, and I'm going to keep repeating iterations until I get two approximations that are less than 0.001 apart. Okay, so let's go ahead and look at what I need for Newton's method. I have my formula, x sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. Now there's several pieces to this formula, but I notice that I don't yet have f prime. However, that's easy enough to calculate. So I know that f prime of x is going to be 3x squared plus 1. Okay, now it's time for me to start my iterative process. But there are quite a few calculations involved in doing this. So I've created a table to help me get to this rule. So if you notice, the columns in my table correspond to x sub n, f of x sub n, f prime of x sub n, the ratio, and then finally my entire rule. So it's going to help me with my calculations as I go along the way. All right, so where do I begin? Well, for my very first iteration, I have to start with a guess. So I'm going to look at my graph and notice that my graph crosses the axis right here, and that's a little bit less than 1. So I just have to take a guess. It looks like it's crossing at about 0.7. So for my first input, I'm going to use 0.7. The next column asks me to find f of 0.7. So I'm going to go ahead and plug 0.7 into my function, and I'll have 0.7 cubed plus 0.7 minus 1. And when I fill that information in, 0.7 cubed plus 0.7 minus 1, I get 0.043. Now the rest of the row are just some calculations, so I'll be right back after I finish that row in.